We're going to look at your turn problem, the first one, which involves solving logarithmic equations. So the first thing I notice is that there are two logarithms and a number. So I'm going to want to bring all the logarithms to one side. So I'm going to have 2 log base 3 x minus log base 3 of 2x plus 1 equals -1. The next thing I want to do is combine these two logarithms using the subtraction rule. However, there is a 2 in front of the logarithm, so I want to be able to get rid of that 2. Not really get rid of it, but put it in another position. One of our rules tells us that I can send this 2 so it becomes the exponent of the x. So I get log base 3 of x squared minus log base 3 of 2x plus 1 equals -1. Now I can combine the logs using the subtraction rule. So I have log base 3 of x squared over 2x plus 1 equals -1. Now I'm going to want to rewrite this logarithm as an exponential or do the loop. So 3 to the -1 equals x squared over 2x plus 1. So x squared over 2x plus 1 equals 3 to the -1. Well, 3 to the -1 is nothing more than 1/3. So x squared over 2x plus 1 equals 1/3. So we solve as a proportion. 3x squared equals 2x plus 1. So bring everyone to one side. So 3x squared minus 2x minus 1 equals 0. This factors. 3x and x, a minus 1 over here and a plus 1 over here equals 0. So we're going to get that x equals -1/3 or 1. Now it's very important that we check our answers to see if we have any domain violations. So I go to the original problem. So let's look at x equals -1/3. So we come over here. Can we take the logarithm of a negative number? No, we cannot. So we throw that answer out. Now let's check x equals 1. We come over here. We place 1 over here, we're fine. If we place 1 over here, we're still taking the logarithm of a positive number, so that's a keeper. So our answer becomes x equals 1.